ionic, covalent, and hydrogen bonds. By ionic bonds, there are electrons gained or lost. An atom gives off an electron or gets one. If the electron gets an electron, if an atom gets an electron, it has too many electrons, and therefore it is negatively, and it is an anion. If the atom loses an electron, it has more protons in the center than electrons, therefore it is positive, more positive protons than negative electrons on the shells, and therefore because it is positive, it is a cation. Covalent bonds are similar, but where the electron is shared. It's not given away like ionic bonds which form ions, but it is shared, and they form molecules. So the shared is basically the electron is basically the atom in the middle of these two atoms which are sharing it. If it is shared between two atoms who have not the same, an unsimilar force of pulling at the electron, then it can be that one, like in oxygen and water, the oxygen is pulling stronger at the shared electron as the hydrogen is pulling at the electron. And that would be now a polar covalent bond, because they are polar. The hydrogen has its electron a little bit pulled more away from it as it has technically less electron, so it is more positive. It has positivity. The oxygen has pulled it towards it. It had become a little bit more negative. It has no negativity, so that is a polar covalent bond. They are polar. Non-polar is if it's between, for example, two atoms which have the same pulling force, and it's just in the middle, non-polar. And the hydrogen bonds. Now, in that example with water, the H2O with the two hydrogen and the oxygen, where the oxygen is pulling stronger at the shared electron in the middle, there the hydrogen has become a little bit positive because the electron was a little bit far away from it. And now that negativity gives it a little attraction force to other, a little positivity of hydrogen gives it a little bit attraction to negative things, for example, oxygen or nitrogen. And that is not strong enough with force in hydrogen bonds to form new molecules, like covalent bonds, where it is shared. But it is enough by large molecules, where there are hundreds of them, to make a link between molecules, for example, or also to give that whole thing, that whole molecule structure and stability, and the whole shape of it. When there are hundreds of them at a large molecule, that is also important in the human body. So ionic bonds, they are gaining and losing electrons, and positive ones are cation, positive ones they have too many protons, and negative ones anion, they have too much electrons. And the covalent bonds, they are sharing, they can be polar, when one is pulling stronger, they are polar, one has positive, one negative, and non-polar, they have equally sharing between those two same atoms, and hydrogen, that is just if it was pulled away in such a polar covalent bond, hydrogen is negative, is positive, and it pulls to another negative thing. That is according to Gerard and Sandra Gabrowski's Principles of Anatomy and Physiology book, on several pages starting on page 30. But this is no medical advice.